Okay, we're going to look at empirical rule example, but before that, let's answer the question that I posed in the previous video. If two events are mutually exclusive, what can we say about whether they are independent or not? We can say for sure that they simply cannot be independent, because if the two events are mutually exclusive, that means what? If one event has occurred, then the other event just simply cannot occur. So knowledge of one event makes the other event's probability certain. So it changes the probability. So it just cannot be independent. Another way of looking at it is the if the two events are mutually exclusive, that means the probability of the intersection is zero. There is no intersection, so probability of intersection is zero. For the two events to be independent, the probability of the intersection must be equal to the product of the two probabilities. So if you multiply two probabilities, probability of A and probability of B, that can never be zero unless if one of the events is probability is zero. So which means that event doesn't even exist. So there is no question of it being mutually exclusive or independent or anything. So if there are two events, okay, non-trivial events, okay, they have probabilities. So if they are mutually exclusive, then they simply cannot be independent. They are dependent. By definition, they cannot be independent. Okay, now moving on, we're going to look at these concepts from an empirical example point of view. So suppose we have a new television program that is viewed by 200 people, 120 females and 80 males. Let's go ahead and enter the numbers. So we have 120 females, okay, 80 males. So let's go ahead and add the two. So that's 200 people, right? So let's go ahead and make them both columns the same width. Okay, of the 120 females, we have 60 who liked the program. So it's about a television program. So 60 likes the program. So now with that, we should be able to figure out the rest of the numbers, right? So this will be that minus that, and we have of the 80 males, 60 like the program. Okay, so we need that. Then that minus that will be the people who did not like the program. So now if you sum across the rows, then we get how many people liked the program and how many did not. Okay. So now we have these probabilities to answer. And so this will be a case of empirical probability. So we will be looking at relative frequency. So what is the probability that a randomly selected individual liked the program? So K is like the program is 120, right? N is 200. Okay, so probability is the ratio 0.6. Okay, if a male in this group is selected, okay, what is the probability that he liked the program? So here you have to be very careful. It says if a male is selected, so that means we know that the person that we have selected is a male. So given, so this is a conditional probability. Given that male has been selected, what is the probability that the person, so the probability we want is liked given male. So K is, now we need to only look at this column. Okay, not these. Okay, only this column given male. So like is K is 60 and N is now 80. not 200, because given male means that's it. The sample space is now shrunk to just male. Okay, then that divided by that is 0.75. See, what is the probability that a randomly selected individual is a female and like, so now there is no if here. So if randomly selected an individual, then we want the probability that that individual is a female and like the program. So here this is a, so that's what we want. That's an intersection. So which means K here is female and like the program. And this is not conditional probability, so our n is 200. So probability is 0.3. What is the probability that a randomly selected individual is either a female or someone who liked the program? So this is either or, so that's our union. So female or liked is probability of female plus probability liked. Remember the addition rule. So now when we add these two probabilities, we have double counted the intersection. So we have to take one of those double counts out. So probability of female, okay, so we have, do we have female here? So probability of female is that divided by that. So that is probability of female. Probability of liked is that divided by that. Okay. Probability of female and liked, okay, so that we have here. Okay. We can even go here and get it, but let's get it from here. So probability of female or liked is probability of female plus probability of liked minus the intersection.